Hey guys, Jake here coming at you with another math lesson today. Here's the problem we're going to be doing today, another integration by parts, but this one's interesting because with this problem we're actually going to have to apply integration by parts twice to get our answer. So let's jump into it. Up at the top here I just have the integration by parts formula written out so that we can refer up to that. But here is the integral that we're going to be evaluating. We're going to find the antiderivative of x squared times sine x dx. So just like any other integration by parts problem, and I've done a couple on my channel if you want to start with those that are a little bit simpler, this one we're going to have to do a little bit extra. So if you don't know where to start, go check out those videos. I'll link them here so you can do that. And then come back to this one. It's definitely an interesting problem to see and one that you want to be familiar with. But like any other integration by parts problem, the first thing you want to do is designate which piece of your function that you're trying to integrate is going to be u and which is going to be dv, or in other words, which piece you'd rather take the derivative of and which piece you'd rather find the antiderivative of. Looking at this, this piece here, the sine x part, whether we integrate or differentiate that, it's just going to alternate between sine, cosine, negative cosine. No matter how many times you take the derivative or the antiderivative of sine or cosine, it's just going to go back and forth between those. So whether we take the derivative or the antiderivative isn't going to make a difference for the sine piece. So it doesn't really matter whether we call that u or dv. However, looking at this other part over here, the x squared, if we find the derivative of x squared, that is going to lower our power by 1 and leave us with just a constant times x, which is a little bit simpler to deal with. If we find the antiderivative, it's going to raise our power by 1, giving us an x cubed, which probably means we're not really going to get in an easier situation by taking the antiderivative. Taking the derivative is going to leave us with something a little bit simpler to deal with. So that's slightly preferred. And since it makes no difference with this other piece, we'll go ahead and say that our u is going to be x squared because we want to take the derivative of that. And we'll say our dv is going to be the sine x part. So now what we need to do is figure out du and v. So first of all, du is just the derivative of u. The derivative of 2x, or the derivative of x squared is 2x by the power rule, right? And then we also need to figure out what v is, which is just going to be the antiderivative of sine x. The antiderivative of sine x is negative cosine x. So now we want to take these four pieces, plug them into our integration by parts formula, and see what we're left with. So doing that will tell us that this integral is equal to u times v, which is x squared times cosine x, times negative cosine x. So we'll just say negative x squared times cosine x, minus the integral of v times du, so minus negative cosine x times 2x. So that'll be negative cosine x times 2x dx. So just to kind of simplify this a little bit, we could pull this negative sign out front, we could pull this 2 out front. So the negative here would cancel with the negative here, giving us a plus sign. And then if we pull the 2 out, we're going to have a 2 out front of this integral. And then we're just going to be left with cosine x times x inside of our integral. So now looking at this integral here, this isn't really that much simpler to deal with. So you can see we still have the integral of two things being multiplied together. However, this integral is a little bit better than the one we started with because we still have some trig function being multiplied by something else, but in this case the something else is just an x instead of an x squared. So we're a little bit closer to having something easy to deal with, but not quite there. So what we could actually do is apply this same integration by parts formula again to this integral, and we might end up with something even easier than that. So let's think about what that would look like. Again, it doesn't really matter if we take the derivative or the antiderivative of cosine x. However, whenever you're applying integration by parts twice to the same problem, you want to make sure that you maintain, what piece you call u versus dv based on the previous time. So here we called our u x squared and our dv was the trig function. We want to again keep our trig function as dv, and keep the u as whatever piece resulted from this x squared, which is just the x piece. So we want to call u x and dv cosine x. We want to make sure that it's consistent with the time before, because if not, it's just going to undo going from that step to that step. So we want to make sure to keep it the same so that we kind of progress a little bit further. So then we need to figure out du. We'll have a dx also in our dv. So du is just the derivative of x. The derivative of x is 1. And then we still have our dx there. And then finding the antiderivative of cosine x will give us v, which is going to be just sine x. So now we can take these four pieces, plug it into our integration by parts formula, and the result would be equivalent to this integral here. So what that means is all the stuff out here in front, the negative x squared cosine x plus 2 is going to stay there. And then this integral is equivalent to our new u times v, which is x times sine x, minus the integral of our new v times du, so sine x times 1. So we're just going to have sine x dx. So now this stuff in the brackets here just replaces what this integral was up here. So we've kind of applied integration by parts twice. You got to make sure to keep this stuff out here and kind of carry that down, because integration by parts just tells us that this integral is equivalent to this stuff that should give us a simpler integral. And in fact it does, because the integral of sine x dx is a much simpler integral, right? We don't have it multiplied by some x or x squared term anymore. So now we just have to figure out what this integral is, and we can just simplify from there. So the antiderivative of sine x is negative cosine x. So if we imagine replacing this whole integral of sine x piece with negative cosine x, now these negative signs are going to cancel. So we're going to get x sine x plus cosine x. And then we also have this 2 that's being distributed to both of these pieces. So let's go ahead and simplify all that out. We're going to get negative x squared cosine x plus 2 times x sine x plus 2 times cosine x. And then, of course, with integrating, we need to also add our constant. So this is the final answer of the antiderivative of x squared times sine x dx. Hopefully you found this video helpful. If you did, I'd really appreciate a like and subscribe to my channel. Like on the video, subscribe to the channel. It's a huge help, great way to support the channel so I can keep making more videos like this for you. Thank you, and see you next time.